Hey guys, this is Abhishek Prasad Yadav and today we are going to learn about chopper fed DC drive. So before starting what is chopper fed DC drives, we have to learn about what is chopper. So chopper is a static device that converts fixed DC input voltage to a variable DC output voltage directly. That variable output voltage is given to the armature circuit, necessary operations are performed. A chopper is a high speed on-off semiconductor switch which connects source to load and disconnects the load from source at fast speed. Choppers are used to get variable DC voltage from a DC source of fixed voltage. Self-commutated devices such as MOSFETs, power transistor, IGBTs, GTOs and IGCTs are used for building choppers. The reason behind its use is they can be commutated by a low power signal and do not need communication circuit. So now we will learn about types of choppers. So basically there are two types of chopper: step-up chopper and step-down chopper. When the average output voltage V0 is greater than the input voltage Vs, then the chopper is called step-up chopper. When the average output voltage V0 is less than the input voltage Vs, then the chopper is called step-down chopper. So here in the circuit we can see Vs is the input voltage, V0 is the voltage obtained across load. And the basic difference between the two circuits is here V0 is greater than Vs and V0 is less than Vs in step-down chopper. So there are also some differences present in the both circuit. They are inductor present in the step-up chopper is in series with the source. Inductor present in the step-down chopper is parallel to the source. These are the basic difference between these two circuits. So now advantages of chopper. Ripple content is the output is small. Peak and RMS current ratio are small. This decreases the harmonic heating of motor. The chopper is supplied from a constant DC voltage using batteries. This eradicates the power factor problem from the circuit. Current drawn by the chopper is smaller than in phase control converters. Chopper circuit is simple and can be modified to provide regeneration, and the control is also simple. So now we will start chopper control separately excited DC motor. Motoring mode of operation. Before starting motoring mode of operation, we have to know that if the source of supply is DC, for example in a battery vehicle or a rapid transit system, a chopper type converter is usually employed. The chopper fed motor is better than the phase control because the armature current ripple can be less if a high frequency chopping is used. So now motoring mode of operation. A transistor is used to chop the DC voltage into pieces and chopped DC voltage is given to the motor. Here transistor acts as a switch or a chopper circuit. Current limit control is used in chopper. In current limit control, the load current is allowed to vary between two given limits, that is upper limit and lower limit. The on and off times of the transistor is adjusted automatically. When the current increases beyond the upper limit, the chopper is turned off and the load current freewheels and starts to decrease. The current falls below the lower limit, the chopper is turned on. The current starts increasing if the load current and the voltage waveforms. By the zooming proper limit of current, the amplitude of ripple can be controlled. So here we can see in the circuit is that when transistor is on, the voltage, that is the source voltage, appeared across the armature circuit. This is the armature circuit, this whole, and this is the diode. So here we can see when transistor is on, current flow from collector to emitter, and this whole voltage, that is V, appears across the armature circuit, that is known as VA, that we can see in the graph here. This is VA. So when transistor is off, in that situation diode come into action. During the off condition, diode come into action and freewheeling action of diode starts. So in freewheeling action, current flow from this region, from diode to armature circuit. Okay, so now we will learn about some duty interval and duty cycle. So now duty interval. So duty interval is also known as powering interval. During the on period of chopper, that is duty interval, the interval lies between 0 to T on. Motor terminal voltage VA is a source voltage V, and armature current increases from IA1 to IA2. That we have seen in the circuit. Here we can see the current is increasing from IA1 to IA2. Okay, so now armature continues from IA1 to IA2, and the operation is described by RAIA plus LADIA upon dt plus E is equal to V, where RA is the armature resistance, IA is the armature current, LA is the armature inductance, E is the back EMF, and V is the voltage across armature. Freewheeling interval. The chopper is turned off at T is equal to T on motor current freewheels through the diode D and the motor terminal voltage is 0. As we can see in the circuit is here, when transistor is off, the diode come into action, and diode when on, the circuit gets short circuited and the voltage across the armature circuit becomes 0. That is, here we can see V is equal to 0 present here. So during the interval, current decreases, that is from IA2 to IA1. Here we can see current is decreasing from IA2 to IA1. So now we will learn about duty cycle or duty ratio. Duty cycle is defined as the ratio of duty interval T on to chopper period T is called duty cycle or duty ratio delta. We can also use a capital D as the symbol. Duty interval is equal to T on or chopper period T. So here we can see in the graph is that 0 to T on plus this particular region is T off. So 0 to T on plus T off is equal to capital T. From the figure, we can calculate average voltage. So VA is equal to 1 upon time period 0 to T on integration of VDT. Solving the above, VA is equal to V upon T 0 to T on integration of dt. So finally we can obtain VA is equal to delta V, where delta is the duty ratio. Then the speed of the chopper drive can be obtained as VA is equal to E plus IARA. Substituting VA from equation 2.59, this is the equation 2.59. We can put this value in this equation and then we can see that delta V is equal to E plus IARA. Substituting K is equal to E is equal to K omega M, we get IA is equal to delta V minus Q omega N upon RA. From the above equation, we get omega M is equal to delta V upon K minus RA IA upon K. Substituting T is equal to K phi IA in above equation, we can get omega M is equal to delta V upon K minus RA upon K square phi into T. This is the equation obtained from the above operations. So now we can go to regenerative braking mode. So what is regenerative braking mode? So after motoring mode of operation, we will start regenerative braking mode. A regenerative braking operation by chopper is shown in figure. In this figure, we can see the regenerative braking mode. Regenerative braking of separately excited motor is fairly simple and can be carried out to very low speeds. In regenerative mode, the energy of the load is fed back to the supply system. The DC motor works as generator during this mode. As long as the chopper is on, the mechanical energy is converted into electrical energy by the motor and now working as generator. Increases the stored magnetic energy in the armature circuit. When chopper is switched off, a large voltage appears across the motor terminal. This voltage is more than that of supply voltage V, and the energy stored in the inductance and energy supplied by the machine is fed back to the supply system. So now we can see in the circuit is, here we can see current direction is reversed in the circuit. So when the chopper is on, the current will flow in this direction and energy is stored. So here we can see is transistor or the chopper is in parallel to the armature circuit and diode is in series to the armature circuit. When switch is on, that is transistor is on, back EMF is having positive voltage. So freewheeling interval starts. So when freewheeling interval start, a current is start flowing from collector to emitter of transistor to this circuit. So in this direction, freewheeling currents start flowing. So this interval is also known as energy storing interval. And here armature voltage becomes 0 due to short circuit condition, because when transistor gets on, this circuit is shorted and then VA across the armature circuit becomes 0. When diode is on, that is duty interval, the energy stored during energy storing interval is go to the source. So here when this diode is on, the transistor is off, the energy stored during energy storing interval in this armature circuit start flowing to the source and the armature voltage becomes equal to V. So here we can see in this interval current is increasing IA1 to IA2, but VA is 0 in this interval. But in T on to T, that is T off period, that is duty interval, we can see VA is equal to V and current is decreasing from IA2 to IA. So next we will see, when the voltage of motor falls to V, the diodes in the line blocks the current flow, preventing any short circuit of the load can be supplied to the source. Very effective braking of motor is possible up to extreme small speed. Energy storage interval. The stored energy and energy supplied by the machine is fed to the source. The interval between t on to 0 is now called energy store interval, and interval t on to t is called duty interval, as we have seen in the graph. So here duty ratio is delta. Delta is equal to t minus t on upon t. From the figure 2.1, that is this figure, we can see VA is equal to 1 upon t, t on to t, integration of v dt, which is equal to v upon t, t on to t, integration of dt, that is v by t into t minus t on. So armature voltage VA is equal to v into t minus t on upon t, which is equal to v into I minus t on upon t. So therefore the speed torque relation under braking operation is given as omega m is equal to 1 minus delta, that is duty ratio, whole into v upon k minus Ra upon k square phi into t. This is all about chopper fed DC drives. Thank you. If you have any query, then please mention it in the comment section.